Myself real quick, I'm Chad Butler. I'm a security nerd. I work for a company called Caliber Security Partners based out of Seattle. I'm their managing director of security services. And got a family, 5 kids, a wife. We live up in Seattle right now. And I love the outdoors. So that's me. The idea for this talk came from a few conversations I've had recently with various both customers and partners that we work with around the topic of application security. Recently, we've had a number of organizations come to us, startups that have built great products, great software products, and they get to the point where they've got something to sell, and they go to their dream customer, their marquee customer, and they try to sell it to them. Companies sold on the product and on the software that they're selling, but then they run it through their security team, and the security team shuts them down. So we've had several conversations where they come to us and say, hey, help us get secure enough to win this business, or help us prove that we are secure. And so in the course of that, and in the course of speaking with some of the large software companies in Seattle, as well as some of the experiences I've had building software security companies, there's a few things that I want to share that I think are really helpful to organizations that are trying to build either just trying to build a software security practice because it's the right thing to do, or because they're trying to sell a product and they can't do it without proving that they're secure. So this is from the Verizon data breach investigation report. I'm sure you guys have seen these before. It's the source of breaches, and unfortunately, this hasn't changed very much in a number of years. Application security, or web applications specifically, are still the leading cause of breaches in many industries. And there are a few differences there, like point of sale breaches in accommodation and entertainment industries and stuff like that. But for the most part, web applications are the leading cause of breaches in these industries. The sad part is, like I said, it really hasn't changed for at least 5 years. I mean, it's been web applications have been the primary source of breaches for a long, long time. And I think there are a few reasons for that. One, the software industry, the software development industry, is changing at a very rapid pace. But when you look at what we're doing in the application security industry, we're still applying the same types of tools and techniques that came about when waterfall was all there was. And so it's no wonder that things aren't changing in terms of the breaches that we're seeing. We're really not evolving as fast as we should. So I want to talk about some of the things that I've seen that may be helpful to you, hopefully things that you can take back to your shops and improve. So from the supplier perspective, you look at the list of companies who have suffered major breaches in the last few years. Many of those have fallen, not necessarily because they're slouches on the IT and the security side, but because they had some third-party vendor, some supplier, who left the back door open and somebody got in. And so, obviously, if you're looking at this list of companies, you're not wanting to be in that company. You're not wanting to have that notoriety. So these software startups, a lot of times it's like, you've probably heard maybe you have, maybe you haven't, the analogy. Starting a software startup is kind of like jumping out of an airplane and then trying to build an airplane as you're falling towards the ground. There's so many things that can kill you when you're trying to start a software company, and it's every day it's kill or be killed. And so this is let's see if the video actually plays. So this is kind of what it's like. You're this gazelle running through the African safari, running as fast as you can, just trying to keep away from your competition, and not looking up long enough to see this tree that's in the middle of the savannah that you run into. So for a lot of software companies, that's what life's like. You're just running as fast as you can. You're running as hard as you can. And it's not just true for startups. It's true for most software companies, or most companies that develop a software product. Developers are focused on budgets, features, the next trade show, getting things built and shipped for that. And oftentimes they don't have the opportunity to sit down and think about security. So the problem with that is that, of course, software purchasers are starting to catch on to this fact and realizing that they have to apply some scrutiny and some due diligence. And what ends up happening is that everybody purchasing software wants to take a more hands-on approach, right? They want to take a look at your software security practice. They want to take a look at everything and find out if you're doing what you should be doing to keep their data safe. One of the conversations I had recently within the last couple of months that really led to this, the idea for this talk, was an organization that, so I used to be a customer of at one of my last companies. And so I went through their software security practice or their software security verification standard as a supplier. I was the AppSec manager for this company. And so I went through this practice. It was very rigorous, very detailed. And what he told me as I went out to lunch with him is he said, you guys broke our statistics. He said, up until you came along, we had a 100% failure rate. And he explained his approach was they wanted software companies to fail so that they could help them get more secure, which seems kind of like a backward approach, but they were actually very, very good about that. But what we see, unfortunately, is that software companies, they'll go out and they'll try to sell to a big organization, and this big organization will send them a 30-page questionnaire with all sorts of questions that they've never conceived of answering. They're not prepared to answer, and they'll take 2 weeks to answer this questionnaire, and they'll send it back, and there'll be all sorts of problems, all sorts of things that they don't agree to. And what ends up resulting is that this will happen. The purchasing company will layer on all of these additional requirements to bring them up to speed from a security perspective. It's incredibly time-consuming for these small shops. And frankly, a lot of those boxes piled on that car are just plain useless. A lot of the security controls that some of these organizations pile on, they're not following themselves, first of all, and they just don't add any value. So and this is the other factor that leads to it. Everybody's a special snowflake, right? There are lots of frameworks and standards out there, but nobody wants to use them because they don't apply to my business. They don't apply to my industry. And so everybody comes up with their own. And so you end up with these security questionnaires and these special audits that they do that you really have no way of preparing for because they're coming from a very specialized industry, from a bunch of special snowflakes. So the advice I like to give to people, plant the flag, declare success. So rather than waiting for somebody to come and say, hey, show me your AppSec program. What are you doing? Waiting for that opportunity to arise, go out, do your research, come up with a good framework or methodology. Really almost doesn't matter what it is. I mean, obviously it does. It matters to you. You should do your homework and find out what's best. But the most important thing is that you choose something and that you choose it for an important reason and that you can back it up. You create your policies and procedures, whatever you need to govern your people, and then start doing it, start living it. Start small and work up from there. But most of these organizations, as they go and vet their suppliers, they're expecting to go and talk to you and for you to say, well, we don't have a security team. Tell us what you want us to do. And that's when you end up like that car with all the boxes piled on top of it. So if you come in prepared, and you almost come in with the attitude of overwhelming them with so much documentation, so much research and justification for what you're doing, that they're going to look at that and hopefully be satisfied with what you're doing. Now, of course, the real purpose is to do it right and do it smart. But we want to avoid having to do a bunch of rework and rethink things by just being smart from the outset. Boeing is actually a company that has a very robust vendor security program. The guy who leads that has done several talks. If you go out and search on YouTube and some of the other video sites, you can see those. But the thing that I really like about what Boeing is doing is that they aren't keeping their questionnaire to themselves. They've gone through it with multiple iterations and they've perfected it. But they're now sharing that with the community and with the industry, so that you can go out and see what Boeing is asking of their suppliers. And if you've got somebody who's asking something that seems out of line or out of the ordinary, it's nice to compare it to somebody like Boeing, who's a DoD contractor. And if Boeing isn't asking for it, it's probably worth looking at to make sure it's justifiable. So you can find this on SafeCode's website. If you go out and look for, under the resources link, it's Principles for Software Assurance Assessment. There's a number of questionnaires or questions that they ask there. They talk about the principles that they go through. And honestly, it's a good place to start. There are a lot of different things that you can do in application security, but if you haven't started your program or you just want some guidance, take a look at this. It's just got a lot of good guidance and principles to go by. One of the questions is this one on the bullet, or on the slide here. Does the supplier implement a secure development process that includes activities for requirements, definition, design, implementation, and test phases? So they're not getting overly prescriptive. They're giving you the freedom to implement things in the way you see fit, but they're also making sure that you hit those different requirements, those different phases of your SDLC. So one of those, the design phase. We always talk about threat modeling. This is one I like to talk about a little bit. So this is a threat model of a very interesting threat. The threat is that if you leave your keys in the car and the car unlocked, somebody will steal it. Which begs the question: did you really need a diagram to figure that out? And so the question I ask, and I'd like to ask everybody here in the room, how many of you are doing threat modeling today? Anybody by show of hands doing threat modeling today? Okay, we got a couple hands. Those of you who are doing it, are you seeing good value out of it? You seeing good support from the development teams? Yeah, some heads shaking. Okay, great. Threat modeling is something that I pushed for a long time earlier in my career, and I've kind of backed off of it. And it really, the reason is that there are a few reasons. One, this diagram kind of illustrates that. A lot of times we kind of know what threats are there. I mean, here you don't need a diagram to tell me that there's a threat if I lock my keys, or if I put leave my keys in my car and leave the door unlocked, it's going to get stolen. I had an experience a number of years ago doing a threat model with a development team. We had all the right people in the room. We blocked off an entire day. We used all of Microsoft's tools. We followed their methodology, all of these things. We were doing it just the way we were supposed to be doing. And we got incredible backlash from all of the developers in the room. And you kind of sense this tension building throughout the day. And it was kind of frustrating. At one point, one of the developers said, "Hey, we already know where the issues are. Why are we wasting our time in here talking about them? Let's go fix them." And it was incredibly frustrating for me at first, because as I tried to explain, the purpose of threat modeling isn't to talk about the threats you already know about, but to find the ones that you don't know about that are out there somewhere and to address them. But as I've thought about that experience later, I realized how completely off I was. Here a developer was telling me that they knew about vulnerabilities that hadn't been fixed, and they were frustrated that we were sitting in this conference room talking about other vulnerabilities that they didn't know about. And looking back on that, I realized we should have ended the meeting right there and said, let's go fix the things you know about. Let's get those documented. But we didn't. Another experience I had, so I had the opportunity to interview somebody who was working at Microsoft at the time on the Bing team. And Bing ships 5,000 releases a year, so multiple daily releases. Don't quote me on that number. That's just what I remember. But anyway, multiple daily releases. And as I was going through this interview, this guy I was talking to, who was very bright, he said that they were doing automated threat modeling. And I stopped him. I'm like, wait a minute, did you just say automated threat modeling? Those two terms don't seem to go together in the same sentence in my understanding. And I asked him to explain what he meant. And he said, well, they were doing things basically they were just looking for flags in the code where they were doing sensitive operations, touching sensitive data, and flagging that for further review. So what they called automated threat modeling was not really threat modeling in the classical Microsoft case. If you've read the SDL book or read any of the threat modeling resources provided by Microsoft, it had evolved well beyond that, according to this guy. And I've thought about that since then. If Microsoft has moved on and started, evolving threat modeling to the point where they're not, and again, don't quote me on this. I'm not a Microsoft representative. I only have this one data point. But to automate threat modeling to the point where they were just doing a very light touch to find out, to drill down on the things that they really need to look at. That was very enlightening to me. Threat modeling worked really well in waterfall methodologies. Something that it's increasingly more difficult to fit into the software development lifecycle when you're looking at 2 or 3 week sprint cycles or daily releases. It's just not feasible to get a threat model in before you ship every release anymore. But certainly there are some things to look at there. I want to introduce a concept that I used at a past job called task level threat assessments. This was meant to kind of address that difficulty of getting threat modeling into the SDLC. So rather than having a multi-hour meeting where we talked about the threats and whiteboarded and all of that, we came up with a very simple 8-question questionnaire. And so it was, does this feature change deal with any of these things? Sensitive data, authentication, authorization, password resets, cryptography, third-party libraries, those types of things. And if the answer to all of those questions was no, we'd say, okay, doesn't sound like this particular change that you're making is security sensitive, so go ahead and proceed. The idea was that we would take this and implement it into the backlog or defect tracking system. So if you're using Jira, you can set up a workflow where you can go through these questions very quickly. The idea is that if all of the answers are no, it's not security sensitive, we proceed. Just do the things that you should be doing anyway. If one of the questions was answered yes, so in this case we're handling password resets, then it would branch out and we'd give them a number of security requirements. Say, okay, here's some specific application security controls that you need to implement as a part of this particular change. And then ideally, what we wanted them to do was to take those security requirements and to put those into that particular task as an acceptance criteria. So now as that Jira or that defect or whatever it is goes through the software development lifecycle and all the steps along the way, development, QA, integration testing, all of these different touch points are looking at these acceptance criteria and judging the success of this particular feature based on whether or not they meet those requirements. What we found is that this gave a couple of benefits. First of all, if you need to show some auditable standard, this produces a great artifact where you can say, hey, X% of our development tasks were evaluated for security. The other thing is you can quickly drill down on issues. If you find an issue that somehow made it into production, you can go back and find the Jira or the defect that was associated with that, find out who answered the questions, and then drill in with them to find out, did they just misunderstand it? Were they gaming the system? Or do they have a lack of knowledge in that particular area? And so you can do some specific training and help them come up to speed in that. The other thing, and this is probably the biggest benefit. It only takes a few seconds for a developer to run through these things. But what it really does is it forces a little bit of a context switch. The developer, for just a moment, is no longer thinking about budgets, schedules, timelines, features, and all of those things, but he or she is thinking about security for just a moment. Forces that context switch. And even if the answer to all of those questions is no, it may raise a question in their head about some code that they were looking at just the day before or the week before, where they notice that it's handling cryptography or it's handling password resets, and they noticed a bug there, or they noticed that it wasn't handling it correctly. So that, I think, by far is the biggest benefit that you get out of doing something like this. Just forcing that context switch. It's a very small one. It's a very brief one, but it forces that context switch in a way that helps developers get into that security mindset for just a moment as they're going through these questionnaires, these questions. And ideally that helps fix vulnerabilities in code that you never would have seen. So some of the requirements, obviously to make that work, you have to have a predefined set of requirements. There are several sources that you can use. CWE and SANS, the top 25, they produce this monster mitigations list, which has just some good best practice recommendations for all development. Also, OWASP provides a lot of really great information that can be used as security requirements. The ASVS particularly, the Application Security Verification Standard, I found was really, really a good resource. That particular standard is written from the context of somebody going through and verifying the security of a particular application. But it's something you can very quickly rewrite, so it becomes a development requirement and a test requirement at the same time. So there's the other cool thing is ASVS is broken out by risk. So there's 3 different levels. I think there's actually 4, but the first level is just no security required, which I don't think applies most of the time. Oops. But it's broken down into those different categories where, on level 1, it might be something that's internal only, not a lot of sensitive data. Level 2 might be something that processes business-to-business transactions or handles sensitive data, credit card information, things like that. And level 3 going all the way up to something where, loss of life is possible, like a air traffic control system or things like that. So you can pull from this list of verification requirements and build out your development requirements. The requirements are cumulative, so you go through and you can rate your applications, rank them by risk, and determine if it's a level 1, 2, or 3 application. And then if it's level 1, you get a certain subset. If it's a level 2, you get all of level 1 plus level 2, etc. It also sets you up for, if you want to get a pen test that is run and goes through the ASVS verification standard, that's something that you can get as well. Which is nice to be able to hand to a potential customer or business partner to show what you've been tested against. So here's an example of how we've set up requirements in the past. We would throw these in a wiki. So basically the idea is, so here's this is straight out of ASVS, ensure that the application is not susceptible to SQL injection. So that's a high level requirement. Then you give them some development guidance. And generally, this would be high-level, parameterized queries, output encoding, input validation, whatever. Give them some high-level input or some high-level requirements or guidance to implement that. Point them out to OWASP or some external resources. But the whole idea is to put it in a wiki so that developers can get in there and say, this is how we do it with our stack. This is how we do it with our framework. This is how we implement it here. So it gives them the opportunity to go in and modify that. The requirement stays the same, but they can modify the development guidance to meet their needs. Same thing on the test guidance. Give QA some guidance to help them test it, some links to external resources and tools, but then they can go in there and make their own notes and help others understand how to do that better. And then those bottom two sections applies to, we broke it out, web mobile versus web service, and then required by the trust level. This was the ASVS levels 1, 2, and 3. And so something that they could quickly go through and see, does this apply to me, and hopefully implement it very quickly. Before I go on, any questions? No. The other important thing to develop, so these are things that I want you to be able to take away to implement cheaply, and these are things that have a lot of bang for the buck. The presentation is advancing automatically. Sorry about that. So these are things that I wanted you to be able to take back to your shops and implement. If you're doing nothing else, these are great things to start with. So secure development training, this is something that you can spend a lot of time and money on. Unfortunately, if you were to go out and buy secure development training for all of your developers, it'd be extremely costly. But some of the things that we've seen that have worked very well, make it hands-on, lab-based. I've developed a number of training courses for developers where I'll go out and get WebGoat and go through those labs, do some. Basically, the framework would be do some slideware that talks about a particular vulnerability, so cross-site scripting. Go through and talk about cross-site scripting, what the risks are, how you discover it, how you exploit it. And then you do a lab, with WebGoat or one of these other deliberately insecure web applications, and give developers the opportunity to actually exploit it in the lab. And as they do that, a couple things happen. One, they get to see for themselves that it's really not as difficult to attack and to exploit these vulnerabilities as they maybe initially thought. And that opens up, it's kind of the light bulb moment when they finally realize that, oh hey, this really isn't that difficult to exploit. It really is risky. For me, one of the really fun demos to do with developers is to come in with Beef, the browser exploitation framework, and show them some of the client exploitation tools, show them some of the social engineering tools. There's a few modules that will pop up a Facebook authentication page. Your login is timed out. Please re-authenticate. Things that'll pop up, an Adobe update notification that will install malware on your system. Things like that. Just showing that, letting them see it, really helps them understand how easy it is to exploit these things. So go through, do the exploitation lab, then you come back, do a little bit more slideware to talk about how you fix those things, secure coding mechanisms and techniques, how you would address that. And then you go back and do the same lab, or not the same lab, but a remediation lab where they go in and they employ those techniques to fix the vulnerability that they just exploited in the previous lab. So that's a training format that I find works really well for developers. They like to be hands on the keyboard, and it gives them the opportunity to explore. Those that already know their stuff have the opportunity to explore and dig in and reach into things a little bit deeper. And it gives you the opportunity, as the internal AppSec person or the internal security person, to set yourself up as the resident expert in that area, so that it redirects questions and things of that nature back to you. In terms of encouraging it, Adobe did a great thing a number of years ago. They came up with a training methodology or training system where it was martial arts belt system. So basically, they had a number of courses that they expected everybody to take. And that was your white level belt courses. And then beyond that, you'd have a number of deeper dive courses on the same topics that would get you to yellow belt or green belt or whatever. And then they had sort of the upper echelon developers that were brown and black belts, and those would be things that would require some research or some additional insight, where maybe you do some research and write a paper, publish a white paper to the organization, or you do a brown bag lunch presentation to the organization and teach them about some security concept. So that was a concept that I really liked, something that worked well for them. You can set up some requirements around that as well, like development teams need to have at least one black belt, or they need to have certain number that are green belt certified or whatever. So that's one way you can do it. The other thing is challenge coins. Challenge coins are great motivations for security training. You can go out to Fiverr and get somebody to design your concept for relatively cheaply. You can put together, go out to a promotional items company and order these things. They're much cheaper than you would think to put something like that together. And then another idea is to use team helmets. You've seen these miniature team football helmets, college and NFL teams. You can buy those relatively cheaply, and then come up with your own sticker. It's kind of like the good play sticker. So whenever somebody passes a course or does something that you want to recognize, you reward that sticker. I saw that happen in a previous workplace that it wasn't security related, but it was designed to encourage good performance, and people really liked it. They displayed their helmets on top of their cubicles and had a lot of fun with it. Dynamic scans, this is something that I don't know how to put this carefully, but we have a lot of organizations come to us and ask for penetration testing, and what we find out when we dig into things is that what they really want is a vulnerability scan with validation, which is fine. That not everybody needs a pen test, but dynamic scans are fairly cheap and easy to do. It's something that you don't need to spend a lot of money on. There are a lot of free tools out there that will do a reasonable job. This is not something that you need to go out and spend $30,000 or $40,000 on one of the Magic Quadrant dynamic scanning tools. Those are great, especially if you're trying to turn that over to your QA team. But something like a Burp Pro license for $300, in the hands of somebody who is skilled and knows what they are doing, is a lot better than a $40,000 web inspector AppSec license, in my opinion. So, come up with a cadence, decide how often you're going to do it, set that up, and it's not going to get everything, obviously, but it'll get the low-hanging fruit, and it'll get the things that will be exploited and discovered most quickly once it hits production. Ideally, do it before each release, but at a minimum, I would say do it monthly, if not more often. Obviously, the more often you do it, the better. But that all depends on your release cadence and how often you're actually releasing code into the wild. Penetration testing, same thing. Come up with the cadence beforehand. How often you're going to do penetration testing. Determine when a penetration test is required. And maybe it's around high-risk changes to authorization and authentication, integrations with third-party, high-risk data compliance changes, those sorts of things. And then the other thing is that I'm sure you all know there's certain things that automated tools just aren't going to find. Stored cross-site scripting. Everyone will tell you that they find it, and that they'll find it every time. But when you really get digging into it, very few of the tools do a very good job in this area. In fact, I'm currently not aware of any tools that do a great job with stored cross-site scripting, even on the static side. It's a difficult nut to crack. So those are things that are difficult to find without a good penetration test. Business logic flaws, again, something that an automated tool is just not going to find. If you can afford a pen test, get that. If not, send some internal folks to a class and start training them. Great way to do it is if you go out and pay a firm to come in and do a pen test, have your guys sit in with them, have your team sit in with the pen testers if they'll allow it. It's something that we allow, we encourage, because frankly, if we've got those people sitting next to us, we're going to do better work because we can shoulder tap them right away and get answers to questions. They're going to learn in the process, and frankly, it's not exactly a black magic art. It's something that we're not worried if other people see how we do our work. So, just kind of pulling it all together. This is how we typically approach things, and this is kind of an agile life cycle, how we would approach that. So you've got generally 4 different phases or swim lanes: plan, develop, test, and production. So in our plan phase, this is where we have our task level threat assessments. This was the the 8 questions that you go through for each change, each feature request, each JIRA, whatever you're doing. Those requirements that come out of that process become the acceptance criteria for that work item. And then as they go through into development phase, so your security or your developers are hopefully coding to those requirements. And hopefully they're also developing unit tests for those security requirements to make sure that they're properly implemented. There's some great stuff out there on test-driven development. If you've heard of that before, there's security test-driven development, which is kind of along those same lines. If you're not familiar with that, test-driven development says that you shouldn't write code until you have a test to make sure it's working properly. So you write the test, make sure it fails, and then you write the code to make that test pass, which seems kind of backwards, but it makes sure you've got great coverage on your unit tests and your functional tests. You can do the same thing for security tests, really. You can make sure that everything is getting validated for proper input, everything is being properly output and coded, and those sorts of things. So if you've got developers who are on board with the test-driven development methodology, try to turn them on to security test-driven development. And there's some resources out there that you can find that give you a good place to start with. Moving into test, obviously dynamic and static application security testing is great. You don't have to spend a lot of money on it, despite what most vendors will tell you. You can get started small and work up from there. And then make sure that whatever you do, you're logging your defects, you're tracking them, and making sure that you're meeting your SLAs for closing those vulnerabilities, and hopefully that you're actually getting those fixed before they go into production. And then moving into production, making sure that you've got good reporting and metrics. If you haven't looked at ThreadFix, it's a great project developed by the Denim Group. It's open source. There's also commercial options. And the thing I love about ThreadFix is that you can pull all of your vulnerability sources into one place. It'll consume your vulnerability information from a lot of your automated tools, as well as allow you to just manually input them. And then you can actually open your JIRA, open your defect directly from ThreadFix. And the cool thing about that is that now you've got your defect logged in the system that the developers use, but you've also got it over here in your system in ThreadFix. As the developers go out and close it, ThreadFix will actually check JIRA, and as the JIRA is closed, it'll change the little bug icon to indicate that it's closed. At which point you can go through and verify that it's closed before you actually close it out of your system. So it's a great way to manage that and track it. If you've ever managed a lot of vulnerabilities in a spreadsheet, you'll see the value in that. And then make sure that you take those lessons learned and go back and provide whatever issue-specific training is needed to address those issues in the future, to make sure that your developers are keeping up to speed with the latest developments. One of the biggest principles that I find that I think is probably the biggest stumbling block for most application security programs is that they fail to win the hearts and minds of developers. So the benefit of taking the time to do this properly is that you'll have developers on your side. They'll be looking for things, they'll be interested, they'll be closing vulnerabilities that you didn't even know existed. I had an experience once, two experiences where we were working with the same team to close some vulnerabilities that we discovered doing the static analysis. And we went to the the project manager or the development manager and said, hey, here's some vulnerabilities we want you to close. And he put up a lot of resistance, wanted to make sure that they were, why we wanted to fix them, wanted to make sure that things were scheduled appropriately and all of this. The same team, as we were meeting with them, there was a developer at the table. And as the meeting closed, he was checking in the code of the vulnerabilities that we had disclosed that he had just fixed during the meeting. So it's activity like that you really want to encourage. I'm sure that the dev manager wasn't pleased by that, but he was making good use of that meeting time. He was fixing vulnerabilities, and frankly, I was happy because he was taking care of the issues that we wanted fixed. If you take the time to win their hearts and minds and get them on board with this, they'll be your eyes and ears. They'll be finding issues in the code that, again, you would never find with your tools or with your testing, but because they're in the code every day, they'll find those things and hopefully fix them without you having to prod and pry it out of them. If you take the approach that some security teams take, which is my way or the highway, those development teams will probably do everything that they can to circumvent you and to get around your process and to not do what you want them to do because they don't see the value in it. So the first thing is, I think, is demonstrate the value of it. Demonstrate that you're bringing value to them. Don't just bring them problems, but show them how to fix it. Bring them solutions. Take the extra time to explain why it's a big deal, why you want them to fix it. Second, go to them. Don't require them to come to you. So use the tools and the processes, the systems that they're already using. If they're using Jira, don't require them to come to ThreadFix. By all means, go and open the bugs in Jira for them, so they don't have to come to you. The whole point is, make it so that the path of least resistance is the secure way. Don't make it so that it's so much more difficult to get through your process that nobody wants to follow. A particular bad experience or bad example of this, I had the unpleasant opportunity to work with a particular software company, very large software company out of Europe, and they had a very, very robust and mature AppSec program. It's very academic, and they came in and said, these are the things you've got to do, and didn't take the time to really explain why. Just this is it. And I did some research and looked at it and did some estimation and realized that to do everything that they wanted to do would have required 40 developers every year doing nothing but those things. So 40 man years per year doing security to implement their process. Took that to the development managers and senior leaders, and they said absolutely not, of course. So it's stuff like that I think we really have to watch out for. That same company, they had a process, a pre-release process that took 2 weeks to get through, where they validated security. It was two week long security check before you could push into production. They wanted to get into more of a DevOps mindset, and so they whittled that down, and they were patting themselves on the back. They got to the point where they could do that same amount of work in 4 hours. So somebody took 4 hours to do all of these questions, answer all these questions, and put together an email that passed that off. And this was seen as a huge win. And of course, 2 weeks down to 4 hours is a huge win. But think about that for a second. If you're that guy that spends 4 hours every day, that's half of your day, putting together an email so somebody can ship software, that's a pretty miserable existence. And it's still 4 hours. If you're shipping on a daily basis or multiple times a day, that's 4 hours per release. It just doesn't work. It doesn't work today. Unless you've got tons of spare resources that you can throw at that. But all of these things can be automated and developed to the point where you don't need to spend tons and tons of time doing that. Another thing, and this was brought up by the folks at Boeing in that software assurance assessment methodology. They really like this ISO 27034 methodology or standard. It's still fairly new in the sense that there's no auditable standard. You can't go out and get a certification to this yet. I've heard it's in the works, even though the website says that it's been canceled. But the great thing is you can still go out and learn from this and align your process and your practice with this. So we got a lot of value out of not being able to say that we're certified by ISO, but we're aligned with this standard. It's an international standard. It's well thought out. And if you go and purchase this standard for $100 or whatever it is, there's some great templates and resources that you can use in that document. Finally, a few words on just the reporting and the metrics side of things. These are things that obviously as you're building a software security program, you need to be able to show that you're making a difference. You need to be able to justify the money that's being spent on that, and being able to show pretty charts and graphs to executives is always a good thing. But I wanted to point your attention to the one on the lower right. This is a dashboard that we came up with that I feel is really compelling. So basically what you've got is your list of applications on the left. Up on the right, or up on the top, you've got your list of requirement categories. And the idea is that if you have no vulnerabilities in that particular category for that application, the light is green. It's a green circle, you're good. If you've got a medium risk vulnerability in there, then it's yellow, and you've got a number off to the side that tells you how many vulnerabilities are there. And same thing for red if it's a high risk vulnerability. So this is something that it's easy for executives to see, where are my application security risks? Where do I need to apply the focus? And anytime you can share this in a way that it fosters a healthy competition between teams and application development groups, it's a good thing. And the final thing that I wanted to leave you with is there's this concept in the startup landscape, the software startup landscape, where Paul Graham has said, do things that don't scale. And the idea is that, as you're starting out, you have the flexibility to do things that don't necessarily work at large scale. So if you're a software startup, like I can't remember the name of the software startup, but they talk about doing not development, but delivery for restaurants. And at first all they did was throw up a website with a phone number, and the phone number went to the founder's cell phone, and when he got a call, he would run over to the restaurant and deliver it to the customer. Those are things that a large enterprise can't do. But as you're starting off in software security, you can do those sorts of things. I had a meeting once with a sales executive from one of the major security tool vendors, and they were trying to pitch us on an enterprise dynamic analysis platform. Very expensive, very feature rich, and looked great. But this salesperson brought with them, I think it was their CTO or anyway, a C-level on their security side, and he said flat out, I wouldn't recommend that you start with this. I'd recommend that you just pick one vulnerability and just test for that. Pick SQL injection, go out and test for it. Make sure you get really good at that, and then move on to the next one. And I don't think the sales executive liked hearing that. We didn't end up buying the tool, but I've thought about that exchange a lot since then. I think there's a lot of wisdom in that. Don't try to boil the ocean all at once. Pick something. If you're struggling with SQL injection, focus on that. Cross-site scripting seems to be a very prevalent issue. I don't think we do an AppSec pen test without finding some form of cross-site scripting somewhere. We don't see a lot of SQL injection anymore, thankfully, except in cases where it's a breach response. But we still see a lot of cross-site scripting. Focus on that. Find a tool, find whatever you can, and focus on that, and then expand from there. Same thing with reporting. You may not have a fully automated reporting framework. That's okay. Put it together in a spreadsheet. Do whatever it takes to get the traction you need to get your message out there. And then as you do that, you start getting traction. You start to win the developers' hearts and minds. Start shining a light on the issue to executive management, and that's when the funding starts coming, when you can start doing things that will scale. So that's it. Any questions? Yeah. Yeah. So the question is, are there web app firewalls or RASPs that can be recommended to help kind of a stopgap while you're getting this program up to speed? Yeah, there are a lot of great tools out there. I'm not going to recommend any of them by name because they all have their pluses and minuses. The only challenge is there that as soon as you put a WAF in place, then your developers might come back and say, well, it's not exploitable, so why should we fix it? So yeah, WAF is a great tool, great technology, but I'd say it shouldn't be a replacement for secure coding and AppSec and all those things. But great question. Any other questions? All right. Well, thank you. My email and phone number up there if you want to contact me afterwards. But yeah, appreciate you coming. Thanks.